Okay, so here what we'll do is we are going to analyze a column member for a particular load and predefine actual load. Okay. Now since we are not going to design that member, design means you analyze the load then estimate the reinforcement quantities. But here we are not going to estimate the reinforcement quantities. We'll assume some reinforcement provided. Okay. So when you do that means you know the reinforcement, and for that reinforcement you want to determine what is the capacity. That time you check this option, reinforcement to be checked. Okay, means you will check whether this reinforcement is sufficient or not. Now we'll assume some reinforcement, let's say in both the directions 3 bars. Okay, so here you can make it 3 and diameter is 20 already given. We'll assume the same thing, and also for transverse stirrups. Okay, now here you can see this will be the look of your member with 3 bars in each direction. So total 8 bars we are providing, and now we'll draw that member. So this column is, I think this story height is 3 meters, so total 12 meter long. You can just assume is a bridge pier or something similar to that. Okay. So for 12 meter long, 300 mm section is very small. Let me increase the size of section. Let's say this is 800 by 800. Now you can provide your support. So you are assuming the bottom to be fixed. Okay. And at this point, we will assume a particular actual load. For example, let's say 20% of means P divided by cross section into FC is equal to 0.2. Okay, we have started. So this is what we are going to do. So now from this you can calculate what it will be. FC we consider as 30. Okay, so use this and this section information and calculate. Yeah.
FC के 30 बोला क्या?
हाँ
FC के बोला 30 FC डस
FC डस 30
FC डस 30
हाँ 0.2
300
How much you are getting?
सर कॉलम का सेक्शन 300 into 300
800 by 800.
800 into 300
Because this is a 12 meter tall column, so 300 by 300 will be very small, so I will increase the size.
3840 kilonewton.
3840 kilonewton. Okay, so calculated load is means actual load is coming to be 3840 kilonewton. Now this you can apply as a joint load. Okay, so you can click on this node, then go to assign, then go to joint load, then force,
Sir,
and here you can select under which category you want to apply. Okay, since already live load is by default defined here, so I am applying this one, but if you want to make it any other category, you can define it first. Okay, and what will be direction?
Sir, maximize.
Sorry. What will be direction for this load? Minus means in the z direction. 3840,000.
Sir, 3840
Oh, sorry,
kilonewton.
this is already in kilonewton. Okay. Let's see. We have decided z direction. Now see after applying which direction it is acting. So you can see now, right? Depends on which degrees of freedom you are selecting for applying the load. Now if you see here, z is this direction and this z is upward, so means upward is positive. That's why we have provided minus. Okay. And you have to define one load pattern. Unit lateral. I'll tell why I'm defining this one. Just you do this now. You can make it as other.
And the minus 8 is.
Minus 3840 minus 3840.
Now again, did you do that? I have defined another load case.
Okay, ma'am.
Unit lateral. Just look at here once again. You have not observed this one. Go to define load pattern. Here you see I have defined this load case unit lateral, then categories other. Okay. We'll discuss why this is necessary.
Sir, 3840 live load था या
Yeah, this was under live load.
live load, sir?
Okay, but it need not be like under live load. You can define it under any category. Now, since I have only one load, so live load I have decided. If you have multiple load, you can decide multiple categories. So select this node again, then go to assign, then again joint loads. Now it is ground displacement.
Unit lateral.
Okay, you select this
Unit lateral.
other type, then here translation x, you can make it as, let's say, 200 mm. So I want to apply 200 mm displacement in the lateral direction. Okay. And here I am using positive, means I will be pushing in the positive direction.
Sir, add to existing करना पड़ेगा.
Yes.
Add to existing.
Sorry.
Add to existing, sir.
No, these are two different load cases. It doesn't matter.
Replace नहीं होगा, sir.
That was force. This is displacement. Any cases are different. Okay. But if you do also, it should be separately, not in the same load case. Sorry. The type is ground displacement written here, but the point where you have applied, it will be applied at that point only, not at this level.
एक ही दिखा है. बताओ तो.
या तो बता रहे हैं, या तो बता रहे हैं। तो दोनों एक चढ़ गए, मैं भी
आ गया ना तो.
तो दिख रहा है।
next we need one load pattern also. In this case, means load time history. For example, you know earthquake time history. You have a predefined time history. When you apply this, the structure follows this time history, and for each of these point, it calculates how much force deformation occurred in the structure. The same approach we are going to apply here. We have a target displacement of 200 mm. Now, what load path this 200 mm will follow, that we have to assign. Okay, maybe it can follow the time history also similar to earthquake, and the peak of that time history will be 200. Or maybe it will follow a linear pattern, means triangular load path. It will start from 0, then linearly increase up to 200, like that. Okay, so we will define one time history for that. So that time history definition you have to make here. Load case, then add load case. You can make it linear static, not linear, we are going to non-linear, so non-linear static. Then previous you can make gravity, we make another load case. And here you have to make as acceleration. Okay, it will be ux, or sorry, not acceleration, load pattern. We have to go for non-linear time history. Non-linear direct integration, yeah. So acceleration u, this is y, this is x. So we have applied the load in x direction, so this will be u1, and here I have to choose this time history. I didn't define any time history, I defined this one now, and scale factor is 1, let's say. Now here also you have to also define the damping. Let's say specified by periods, then I don't know what is the period of this structure. For example, 1/10 of number of stories if you take, maybe 0.3 seconds we can consider. We can analyze this for nodal analysis, then determine the period. Okay, so just approximately I am writing here 4.4. Second period will be 0.0. The damping we are going to consider 0.05. Okay, now here these things we have to tell it again. I didn't define any time history now, so we will define and come back to this point once again. So definition of time history you can make here. See, so to make it easy, we will follow a linear time history. Okay, means it will start from 0, then linearly reach up to the maximum displacement defined. Okay, so you can make at time 0 what is the value, then at time 1 what is the value. Okay, so at time 0 let it be 0, then modify, then at time 1 it is 1, means maximum. Okay, so it will follow this time history path. Now we can go back to this load case, then see which one is applied. So this is that time history what we have edited now. Okay. Then we can consider P delta also, and number of output time steps. So the output file what will be generated, how many points you want in that. Okay, we have applied 200 mm displacement. Let's say 200 and output time step size should be, your time history definition is 1, 0 to 1. So this multiplication 200 into this should be equal to that whatever is applied in your time history. Okay, so if you want to make 200 into this equal to 1, how much this should be? 0.0005, right? Is it?
5 into 10 to the power minus 3, sir. 0.
5 into 10 to the power minus 3.
Yes, sir.
So 0.005. Okay. You got this concept why it is coming here. You define the time history. There the length of time history was 1. Okay. So here when you are making the time steps, so multiplication of number of steps into step size should be equal to that 1. Okay.
सर वो टाइम पीरियड वाला कैलकुलेशन जो डैम्पिंग में जाकर कर रहे थे एक बार
टाइम पीरियड
डैम्पिंग में जाकर के मॉडिफाई कर रहे थे उसको
this period you are talking about.
Yes.
This actually come from model analysis, but we have not yet analyzed this. We'll analyze this for model behavior, then check and update this time period.
The second one is for the second amendment.
Sorry?
The second.
Yes. So if you want to see it now, let's analyze this for model behavior and check. So here you can see this is your first mode period, then the orientation is y direction, the maximum participation where you can see that will be your direction. Okay, then the second mode, this is x direction. So x direction mode we are going to consider here. So this will be our first mode actually. Okay, then what is the second mode of x direction? If you see this one, this is again y direction. The maximum participation is in y. Then the next one, this is in x direction. So this will be our second mode of x direction. So what will be your period? First period is 0.35 and second period is 0.06. Okay. Now see how much we have given. Okay, it was close. 0.35 and 0.06. So I think we did everything except hinge. Now we have to define the hinge. First we'll see with respect to lump plasticity hinge. Then we'll go to the fiber hinge. Okay. So select this. Now see, when you are defining the hinges, since we have defined this level, so this whole member is not considered as a single member. For each level it is considered as a single member now. Okay, but it doesn't matter. When analysis will be carried out, that time it will be considered as a single member only. Okay, but when you are extracting the result, you can see result at each of this level because of this level definition. Doesn't matter. Okay, so we'll apply the hinge only at this point, not for other points. Okay, so we have selected this bottom member, then go to assign, frame, then hinges. Okay, here you can decide your hinge. First, by default it will be considered as auto hinge, means software is by default based on your section properties, it will create one hinge. Okay, then you can decide at what point you want to define that hinge. So I have chosen distance from I end offset. This is I and this is j end. Okay, so from this point, at what distance that you have to give. Okay, so this you can consider as, first you have to calculate the length of your hinge. Okay, so normally the hinge length is considered as half of the section depth. If you do not have any other information available, so that is a thumb rule. The section how much you have, half of that section is considered as the length of hinge. Okay, so now the depth we have is 800, right? So the length of hinge will be 400. Okay, so this 400 you have to apply here. Okay, so the center of that hinge will be considered as the point where we will be defining that hinge. We have total length of 400, so center of that means 200. So at an offset of 200 I will apply that hinge. Clear? Distance from end is it is in meters, so 0.2. Got it, right? How that 0.2 is coming? The length of hinge first you calculate, then at the center of that place. Okay, so after doing this, you have to click on this add button. Then here you define the hinge definition based on what reference. Okay, you have this reference ASC 4117, then ASC 4130 with EC 8 2005 recommendations and only 4130. Okay, so latest available is 4170. In class I have also introduced 4123, but that is not available here. So the latest will go, which is 4170. Then here you have to select this one, concrete columns, and this is going to be, let's say, P M2 M3. Okay, P M2 M3. Then okay, I have to define one gravity load. Before defining that, let us define a gravity load. No, this gravity load should be defined as a non-linear. Okay, the gravity load what you have, that is linear, but for this you need the non-linear behavior. So you can calculate it. Sorry, defining gravity load case here. Gravity, then non-linear static, and here you can add the dead load will be there. Then what else you have? You have axial load also, like, okay, so these are coming under gravity load. Then you can consider PW. So now this gravity load, and here see one more thing, when you have defined that pushover load case. Okay, we are defining this as a time history load case, and here you have to decide the previous. Sorry, this is mass source, this is there, and you have to click on this one. Continue from the state at the end of nonlinear case. It means first it will analyze for the gravity load case, then whatever the response was obtained from that gravity load case, that will be considered the starting point for your pushover. Okay, so here you have to choose this gravity. So now here you can choose this gravity load option here. And what are the parameters you need? Concrete column behavior not controlled by inadequate development of splicing. So you can mention whether this behavior will affect your member or not. Okay. So based on what detailing you have used, you can choose this option. Mostly this is the preferred one. You do not want your member to be affected by inadequate splicing. Okay. Then shear reinforcing ratio from the current design. We have already mentioned our reinforcement, so it will be calculated automatically from that. Then shear demand at flexure yielding by shear capacity. So this program will calculate. Okay. Then shear reinforcement from current design. This already have specified, so it will be considered automatically. Deformation control, then load gain capacity, drop load after point E. This means that capacity force deformation curve you have seen like this. Okay. So the last point is E. After E it will drop suddenly. Okay. So now you can see this hinges defined here. Okay. So if you want to check these hinge properties, you can click on this option. Here you can see this is the hinge provided at 0.2 meter, and if you want to see how this hinge look like, you can go to define section property, then this option, and click on this show generated hinge. Okay, then you can convert auto to user and modify show property. Then here you can see what it does is, when you apply this kind of hinge in case of column, it will create a interaction surface. Okay, in interaction surface what you have axial load, then movement in orthogonal directions. Okay, so now the software has by default created some axial force, for example 0 axial force, then 5760 kilonewton, then 11,520 kilonewton. So these are the axial force corresponding to which a software provided some movement capacity in all the directions. Okay. So if you see those movement properties, you can see here. See, this is corresponding to that axial force. Okay. 11,520, and this is the moment rotation curve corresponding to that, and this is for 0 degree angle. Similarly, if you change the angle 90 degree, so this is the property. Now it is not changing because it is symmetric, provided as symmetric. Okay, you may have unsymmetric also in certain cases, but here it is symmetric. Similarly, you have a 270 degree angle. So do you understand why this angle, so many angles are coming, and what does this different axial force indicates? Otherwise we can explain if you have any doubt. Okay,
Sir,
so
this
I guess
is-
you understand.
Sir, this is lumped mass
Sorry?
method. Lumped mass method.
Yeah.
That's why that is showing that.
Yeah,
backbone.
that's why this is load deformation curve. Okay, this is similar to what you see in SC41. Maybe the shape is after yield point strain hardening is steep here. Okay, so this you can change here, but we will not do this, leave it. Then what else you can see? Interaction surface also you can see. See, this is the interaction surface. Here you can change the angle, view, elevation, then you can change in plan also. So this is like a ball shape. Okay. Here you have 0 to 360 degree angle, and informations are provided at certain interval of angle. For example, I don't know at what angle it is given. Let's check. 4 angles are given: 0, 90, 180, 270, and it is considered as symmetry. So here you see moment rotation dependence has no symmetry. Okay, this is asymmetry. Okay, but the properties what is given here, that was symmetric. That's why the curve is coming to be symmetric. Okay, or you can select this one. Moment rotation dependence is circular. Okay, now you have provided at 0 degree, then 90, then 180, then 270. Then intermediate angle will follow the circular option. Okay, so this is done. Now let us analyze this structure and see what is the behavior.
सेलेक्ट कर दिया होगा इसीलिए हो गया ऑटोमेटिकली हो जाएगा। हाँ इसको डिलीट कर दो, इसको डिलीट कर दो, हो गया। उसके बाद इसको क्यों डिलीट करो, इसको डिलीट करो। अच्छा अच्छा हाँ इसको डिलीट कर दो, इसके बाद इसको हाँ डिलीट कर दो। ओके इसको क्यों डिलीट कर रहे हो,
डिलीट हो गया ये ये पे डिलीट नहीं हो रहा।
रहने दो, कुछ प्रॉब्लम तो होगा नहीं, ज़्यादा है जल्दी से। कॉपी डालने लग गया
Sorry, we did a little mistake here. So just to correct it, in the load definition, we have to change this to load pattern instead of acceleration. I'll tell you why. And here we have to choose this unit lateral, what we defined for 200 mm displacement. Okay. And here you can decide that load pattern means the linear pattern what we have created. Okay. So why? Because if you choose the other option, acceleration, this will be applied at the bottom base, but we do not want this one. We want our load to be applied at the specified point. Okay, so in this case you have to go for this one. Okay, and here in the load name, this unit lateral where we have provided 200 mm displacement. Okay, and the pattern will be this one, unit. Means whatever linear pattern we have created. So now it is fine, we can analyze. And one more thing is, at this point you have to 1 minute, we are actually analyzing in x direction. So this is our x. The direction where you are applying your load, that should be provided with some restriction, means movement should be restricted in this direction, then only it will be able to calculate the reactions. Okay, what I mean is, so I want force and deformation to be measured at this point. Okay, I am applying the displacement, not force. Let's say the displacement delta I am applying. Okay, so for this delta I want force to be calculated, reaction force. Okay, so when this reaction will be generated, when it will have certain restrictions here, movement restrictions. For example, I have some movement restriction provided here. So when you apply this displacement, it will, this reaction point will try to prevent that movement. So how much reaction is generated at this point, that will be recorded. But suppose you do not provide any restriction, this is free to move. Okay, so that time at this point there will be no reaction. Okay, so you apply whatever displacement, but reaction will show as 0. That's why we will provide one restriction here, like hinge support or hinge support here. So when you apply this deformation, so this structure along with this support will move, and because of this support it will record the restriction, means reaction forces. Okay. So at this point we will provide a restraint which will be restrained in x direction. Only the deformation will be restrained, not the rotations. Oh, sorry. So you select this joint, then go to assign, then join, restraints, and okay, only x translation is restrained because we will be recording our reaction in this direction. Okay, Other thing you can remove. And let's say restraint Y also, because sometimes what happens, because of irregularity it will try to deform in Y direction. I do not want that one. I want to specifically go in X direction.
Sir,
Yes.
we have to translate that in X direction, sir.
Yeah.
Then, sir, why are we giving restraint in X
So
direction?
this restraint is for recording the reaction forces. We are applying the displacement, not forces. So when you apply displacement, the structure along with the support will move. Okay. But the support what you provided, it will help you record the reaction forces. If you do not provide this restraint, you will not get any reaction forces generated. Now let us analyze this one and see what is the result. So here you can see this is the deformation and your hinge color changed. Okay. Maybe we can see this animation here. Can you see this? So actually this is not coming in negative direction because we have provided only positive. Okay, so you should go in only one direction. But since it is playing animation, so it is repeating. Okay, now let's see the force deformation curve. Display, then we have to go to plot functions for hinge behavior
लगाया था
differential.
200 डिस्प्लेसमेंट का वाई डायरेक्शन में
Why?
Here you can see,
सारा डिफॉर्मेशन एक्स
see this was the definition of hinge. The red color what you
Sir,
see,
X में डाला.
this is the hinge what we have defined. And this blue color is the actual behavior after analysis. Okay, so it has come to this point, then up to here, then analysis stops. Okay, maybe we can apply little bit longer displacement instead of 200. Let's see what happens. So instead of 200, let us apply 2000 because this is 12 meter long, so 2000 is reasonable. Yeah, now you can see this is our defined hinge and this is the actual path followed by the structure. Okay, so after this point when it was coming to the nonlinear range, so this is because of failure, maybe your steel ruptured or something happened, so it is following this point, then after that reaching 0. So our displacement was more than the capacity of the structure, so after this point it is showing some unrealistic behavior. Okay, but up to this point you can say, you can consider this. Okay, so and this is for okay.
So time second 0, what is
No,
that?
time
meaning, sir?
second 0 means, see, you have this dot you can see. So when you change this time, it will move, this point will move, and you can track this movement at what point of this curve you have at that time. Let us try to plot this. Go to display, then plot function, and I want base fx with displacement. So base fx is there, I have to plot for root displacement. Join the displacement. And component is ux, that is correct. So here you see this reaction forces, then displacement. Now if you track this displacement, you see this is following a linear pattern, increasing at, for example, 4, 10, 20, 30, 40 like that. So up to maximum how much we have provided, 2000. Okay. So you can plot this curve and see how it looks like. Don't worry, the shape is odd, but it will not be. Let's say I want to keep it as 300. Then this will be 0 to 2500. So this is what you are getting for this member. See, up to this point is relevant. The point where this curve is touching the zero line. Beyond that, it is irrelevant. Okay. Just your analyzing software is giving you some results. We have to understand what you have to consider, what you do not have to consider. Now, the peak force what we got is near to 1000 kilonewton, and at a displacement of around 40 mm, you can say. Okay. So up to 50 mm, sorry, 50, 60, 70, let's say 70 to 80 mm. After that, it completely collapsed. Okay. Now this force multiplied by the distance, you will get moment, right? So just to cross verify, if the peak force is 1000 kilonewton and your member is, I think, around 15 meter, not 12 meters, but we are doing. Let me cross check this one. See here, peak force, how much we are getting? This is 5 and into 1000, 5000 kilonewton meter. Okay, this is the peak force you are getting here. You see the plan, 12 meter. Okay, this is 12 meters, so 12,000. You should get at least 12,000. If there is something wrong with the curve.
मैं देखता हूँ क्या तुमने सही
इसका किसका है?
ये तो मेरे से
कितना आ रहा है?
हाँ वो है कितना है वो तो मेरे कितना है ठीक तो आ रहा है शायद तुमने उसको कॉपी नहीं किया है उसने
Okay, actually this result is coming something like weird. We will analyze this structure with lump plasticity hinge and check maybe this hinge actually in real we do not use this hinge. It is very much difficult to define this hinge. So we will see with other type of hinge and get back to this point again.
माइनस आ रहा है इसको सिंपल करूँगा
We will define fiber hinge now.
तो देखिए तुम्हारे बराबर ये डेढ़ को कम क्यों आ रहा है
ऑलमोस्ट
कितना आ रहा है
347 391
See, when you define fiber hinge for columns, normally we select this property fiber T M to MP. Okay. Then here fiber definition options default from frame section. You can consider this one. So based on your section, software will by default create some element fiber size, or you can go for user defined where you will define number of fibers for your section. So that will be again taking time. So instead it is better to go for this default option. Okay. Then hinge length you have to decide here. Okay, we have discussed this hinge length to be 400 mm, right? 400 mm hinge length.
सर 200 mm
No, that was half of that.
yes
Hinge length we calculated is 400. Then the name you can mention is fiber hinge. And select this, assign space hinge, and you can select this fiber hinge. This one you can delete. Okay. Then fiber hinge, the same 200 you can mention here, 0.2. And so when you define fiber hinge, you do not have to mention the code like earlier how we did. Okay, this you do not have to do here. So now you can see fiber hinge is written. Let us again analyze the structure and see the results. I think now it is behaving a little bit appropriately, but before discussing this, let us first get the displacement curve.
कैसा रहा है?
18 अच्छा मेरा ये तो बच्चे तुमने कैलकुलेट किया था?
हाँ कैलकुलेट किया।
1.181 था।
हाँ हाँ, और इस तरफ का अलग होगा ना?
1.161 तुम्हारा शायद वो गड़बड़ होगा। मेरा वो चेंज होगा शायद 4.25 जो आ रहा है वो कैलकुलेट करा था 4.6 ये इसकी वजह से होगा।
हाँ तो कैलकुलेट किया तुमने 4.6 ही होगा वैसे सबका 4.6 होगा।
नहीं गड़बड़ है सर, अप्रॉक्सीमेट कर दिया और अपने में ये स्टैक की डेप्थ जो थी उसे लोग सर ने 275 250
अच्छा वो कैलकुलेट करना पड़ेगा। वो बता दो कैसे करेंगे? हमने वो मैंने डायरेक्ट डाला है।
एक बार मेरी वाली वैल्यू डाल के 4.125 डाल के देखो यहाँ पर 4.125 डाल
हाँ भाई तुम्हारा जितना वो टच वाला नहीं है। हाँ 19 और 16 और फाइनल बैलेंस कितना 350 380 तुम्हारा कितना?
यार सर ये क्या
380 420
अब इसमें क्या
फिर भी कुछ और नहीं।
ये तो
वोट कहाँ पड़ा है?
ये जो होगा वो यही होगा।
हाँ
ये कैसे
किचन होता ही है समो 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 वो कुछ भी नहीं। हाँ दोनों
सेम ही आएगा।
अच्छा फिर क्या कैलकुलेट करना है? कैसे कैलकुलेट करना है?
Okay, look here. So actually I was having doubt in the result. So what I did is we can cross verify here. You can go to this option. Then this is the load case and this is the maximum time. And here you can see how much of movement is generated. And if you track here, the movement maximum is 1203 kilonewton meter. Okay, and corresponding shear is 590. Okay, so now this you can compare with the plot function what we got if it is coming in the same range. So ignore this. So PF1 is displacement, then PF2 is reaction, joint reaction,
एमएल से भी टेंशन का कुल
जो इसका टॉर्शन होगा वो इसका लॉन्गिट्यूडनल होगा। अब ठीक है
एमटी एमटी होगा ये तुम्हारा 46 plus gutter conduct plus
बोलेगा क्या पहले देखो वहाँ पे 249.7 क्या है टॉप रोड का टॉप लेवल है
रुको
उसमें से माइनस करोगे पहले बियरिंग कोर्स 49.7 माइनस 0.075 देख गया फिर उसके बाद फिर स्लैब डेप्थ भी माइनस करो प्लस 0.3 हो गया फिर 2.5 भी माइनस करो
2.5 क्यों
गर्डर भी है ना बीच में फिर बियरिंग जो है उसका भी 50 नंबर बियरिंग आएगा ना बियरिंग भी 50 नंबर कितना बियरिंग 50 नंबर इसको माइनस करो
ये अटेंडेंस क्लब
सबने पेपर पे करते हैं
सबने साइन कर दिया
इसी में कर दो
वन लिखो
समझना
हाँ समझ में आया
46.3 आ गया ये सर ने ऐसे क्या गड़बड़ करा है जो 46 कैलकुलेट करके आया है ना देखो क्या करोगे तुम सबसे उसमें से माइनस करोगे इसको तुम्हारा वो डेप्थ पता चल जाएगा और प्लस 1.2 ऐड करोगे तो ये बच जाएगा 1.25 तो ये है ना
हाँ
पहले इसको माइनस करोगे जो सर का दूसरा है वो
सही है।
कैलकुलेट कर दिया है इसको
हाँ
246.3 246.775 कर दिया
हाँ तो चेंज हो जाएगा कितना आ रहा है 4.125
आया
हाँ हाँ तो
इसमें ये आपको थोड़ा नीचे भी चेंज करोगे ना सारा
बहुत कम
350 और 380
तुम्हारा इसलिए ज़्यादा आ रहा है वो इसलिए ज़्यादा आ रहा है ना वो इसलिए ज़्यादा आ रहा है वो इसलिए ज़्यादा आ रहा है क्योंकि तुम्हारा डेड लोड मेरा डेड लोड कैलकुलेशन अलग वो लास्ट में सब लोग सही कर देंगे मैं भी सही कर दूँगा लास्ट
okay so but what is correct actually for this member how you can verify is I just tried to cross check this one what I did at 10 second distance the force is approximately 400 you can say okay now if you check this with this member behavior this is at 10 second actually the relative distance will be 0.005 because our peak displacement was 2000 right so 10 second is 10 by 2000 it will be 0.005 okay here you can check the shear now this is in terms of story shear so you have to calculate the base shear so sum of all the story shears okay so if you add this at the top shear it is 721 then here it is 287 minus so 721 minus 287 then in the next year it is minus 39 then in the next year it is plus 40 so if you sum up this you will get around 410 something okay so that you can compare here this is close to 410 or whatever you are getting okay so actually this is just a random number so I may not have idea whether it is behaving correctly or not so like this you can cross verify if you have doubt okay it the curve what we got it looks like something unrealistic so it is very difficult to judge whether it is correct or not okay so whatever we defined earlier also in the pipeline if that was sorry in the PMM interaction if that was also correct and this is also correct okay so this is how you can define the hinges in columns and beams either you can prefer the fiber hinge. Mostly in case of column, we go for fiber hinge, because if you apply the previous one, what we have applied, that was interaction hinge. So that is very much difficult, because you have to define number of points, number of axial loads, then number of angles. For each of those points, the load displacement curve should be defined separately. So it is very difficult. But fiber hinge, it is easy. You just define a fiber section, then gives restraint properties. Okay. In case of beam, you can define that EMM interaction hinge, although there P will not be there, only M will come. Okay. So I think this is clear. Today we have discussed solid element theoretically, then fiber hinge and lamp plasticity hinge with some demonstration. So if you have any doubt, you can discuss. Otherwise, you can practice this. The building what we have modeled, there you can assign this. Okay.
Sir, we will assign on all the columns
Yeah.
at base.
In that case, in the building, first we have to design the building. Here what we did, we have provided some reinforcement, then the option you have chosen is to be checked. But in your case, you have to first design the building, then based on the designed output, the hinges will be created. Okay. Although we are going to discuss these things again in the class when we take up that building part.